Yeah, he didn't say specific to homework or tests. So.
Okay.
And maybe that's why they have all the hard numbers like that, is because they just figure we're going to use it anyway.
Exactly. That's what I finally figured out today. I was sitting there thinking, why did they put such hard numbers? And it's because they wanted us to do it with Wolfram Alpha, and they didn't think we were going to have to do all that math. So.
Yeah.
So that function represents the rate of flow of money in dollars per year.
Oh, this is the one that we got wrong yesterday that we were trying to...
Well, this is 14.
Oh, this is 15. It looks like the same one.
Yeah, it's similar. Let's see. So if I remember right, present value is equal to the integral of the function times e to the minus rt dt. Is that correct?
Yes.
And assuming a 10-year period, so that would go from 0 to 10. Okay, so we've got the integral from 0 to 10 of 4,000 e to the minus 0.01 t. I thought r was supposed to be, e to the minus rt. Why is that 0.01 instead of 0.04? You know, oh, okay. So what we have then is that's our function, and we need to multiply it by e to the minus 0.04 t dt. Right?
Yeah,
this is the function, and it's supposed to be the function times e to the minus rt. Well, r is 0.04, so this should be right. And this is the same as before we put it into Wolfram Alpha. Let's at least combine it. So, in fact, we'll take the 4,000 out, and we're going to end up with e to the minus 0.05 t. Is that correct? E to the minus 0.01 t times e to the minus 0.04 t. Add exponents, get minus 0.05 t. So we'll let Wolfram do the hard work here. And we want 4,000 times nint, which stands for numerical integral, of e raised to the negative 0.05 x. Negative 0.05 x. Oh, I didn't do it right. And then, let's see, comma, 0, comma, 10. Now, if you're using the nth from a calculator, then you need Wow. Hold on. Put my mouse away here. What in the world is going on with my computer? It does this every now and then. I woke up in the middle of the night, 2 a.m. last night, and my computer had started playing one of my recordings.
That's weird.
Weird isn't the word for it. It's like somebody was in my computer, like right now. I'm not doing this. Gosh. E raised to the negative 0.05x comma 0 comma 10 So the result is apparently 31,477.5. 31,477.5. Is that right? 31,477.5. That's what I did. I took the 4,000 out of the integral, and I multiplied it by f of t, which was e to the minus 0.01 t times e to the minus rt, which is minus 0.04 t. Nah. Can't be that. Okay, so it's e to the minus, I'm going to go back and put in another e raised to the minus 0.04, just in case that, I can't imagine that that's going to make a difference. We got e to the minus 0.01x, e to the minus 0.04x. I guess I need one more parentheses. Am I reading that number right? 31,477.5?
Yeah.
This is the same problem we had on 14. We had
Yeah.
everything that looked correct, but our answer didn't. Now, we know what the accumulated amount of money is. It's going to be, the accumulated amount of money is E, it's the function f of x times this. So, we got a problem here.
Just get the first one wrong again, I guess. Get the second
Yeah.
part of it.
In other words, exactly. That's the only thing I can think to do. Oh, come on. Are you kidding me? Wolfram alpha didn't give me it to 2 decimal places.
Oh, jeez.
Let's go back and look at that, why they didn't. How can that be? Wow. I guess I'm going to have to improve my Wolfram alpha. That's crazy. Why wouldn't Wolfram alpha take that out to at least 2 decimal spots?
I don't know. It could be an error in the program, too.
What do you mean? Oh, you mean this might not be the correct answer, 0.55?
Yeah, it could just be 0.5 and he typed the answer in wrong or something.
Sure seems like Wolfram alpha would have given us an extra decimal if it wasn't 0. I just assumed it was 0. Clip and share, enable interactively, copy, plain, customize, and save data download, enlarge. It doesn't do us any good. Well, do you have a calculator?
Yes.
Do you know how to do NINT on your calculator?
No, I don't.
The only difference when you use NINT on the calculator is you have to do NINT of the function, comma, x, comma, 0 to 10. Whereas on Wolfram alpha, I don't have to put that it's a function of x. It knows that from this part. I was thinking, and my calculator's not working, so I can't do this on anywhere other than Wolfram alpha. All right, so what should we do here? Okay, so the accumulated money flow at t equals 10 would be f of 10 times that number. So,
Times that?
well, f of 10 means we're going to substitute 10 for t, which gives us 4,000 e to the minus 0.1 t times this number.
Okay.
Let's see here. We want 4,000 times e to the minus 0.1x times this number, 31,477.55. That look right? In other words, it's the function times the present value. Well, the function evaluated at 10. So that's going to be 4,000 e to the minus 0.1. 4,000 e to the minus 0.1. I don't need that x in there. All right. Well, how come they gave us 6 decimal points this time?
I don't know.
In the last one, they gave us 1 decimal point. I guess we put this answer in there. What are we supposed to round it to? The nearest cent? Criminy. The nearest cent. More digits. Wow. All right, what do we got? We got 1 times 10 to the 8th. Let's see. 1, 7, 5, 4, 7, 6, 0, 9, 9. So I want to move my decimal spot 8 spots over. 1, 2, 3, 4, 5, 6, 7, 8. And there is a 4, 4. So this last decimal is 4. So it looks like 117,547,609.94.
All right.
Hold on, let's see, that's right, because if I had 1 times 10 to the 6th, that would be 1 million. So 1 times 10 to the 8th is going to be 100 million. So yeah, that should be right. A lot of money. 117,547,609.94 rounded to the nearest cent. What's the chances of this being good? It's e to the RT, not minus RT. So we need to take e to the 0.04 times 10. So e to the 0.4 times that number. Let's do it again. E to the 0.4 and there's no 4,000 in front of it either. I wonder if we did that wrong yesterday. Oh no, yesterday we got the first part wrong and we got the second part right.
Yeah.
So it's e, it's not negative, it's positive. So e to the 0.4 times that number. Okay. What is that? That is 48450.81. Let's just make sure that we're doing it right here. E to the 0.4. E to the RT is e to the 0.4, or is it? Yeah. Times 10. So that would be correct. Okay.
Yeah.
So this should be right.
Should be. Who knows with the my math lab?
I know.
Isn't that the same answer as the first?
No. No, my first answer was this huge 117 million.
No, I mean like part A.
No, because part A, this part is the present value. Just the part to the right. The integral and everything on the right. In other words, the integral of 0 to t of f of t e to the minus rt dt is this number 31477.55. So we have to multiply that by e to the rt, with t being 10. So I think this is going to be right this time. That did seem like an awful lot of money. Must have been more digits on that first one that I could have clicked, although I don't remember seeing it.
Neither do I.
I don't know what to tell you. I don't have any clue as to what we're doing here.
That's alright, I'll come back to that one.
All right. So what do we want to do here? We'll
Just go to 16.
Yeah. All right, let's use Wolfram alpha again. Okay, so we want the nth of this function, 1200x minus 100x squared. Comma 0, comma 10. Excuse me, that's not right. We've got to multiply that by e to the minus rt. E raised to the minus 0.04 t. Well, they're not even going to give us a solution here. How nice.
There's got to be more stuff.
An attempt was made to fix mismatched parentheses, which they must have done it correct. Yeah, I need a bunch of parentheses here at the end. Let's see, I got 1, 2, I need 2 parentheses. They got it right anyway. Why didn't they give us a number as an answer?
Maybe now it will. So maybe one more.
Yeah, you always have to have the same number. No, you have to have the same number right as left. I got 2 left, 3 left. I got 1 right, Need one less. Okay, there's f of x, 1200x minus 100x squared times e to the minus rt dx. All right.
I can just plug that in my calculator right there, right? The 80,000 e to the negative 0.043.
Yeah, let's get a number for that.
So how would I, because we don't have t yet, right?
Well, it's this evaluated at 10 minus that evaluated at 0, and that evaluated at 0 is going to be 80,000 over 3, because this will be 1 when I plug in t of 0. That should be the present value.
Okay, I got a negative. Would that be, that's not right. Oh, let me try that again.
Actually, that makes sense that you'd get a negative.
Yeah, I have to. It's definitely a negative. Negative 8,791.47 rounded.
I wonder if I'm not doing anything wrong with these limits of integration, because we actually did it correctly the last time. Notice they've done a Taylor series here, or Maclaurin series rather. They've expanded it about the center, t equals 0. That doesn't help. That is going to be a particularly difficult integral to find. That is not going to integrate easily. I see what's going on. I've defined everything in x, and then I use a t. I got to make this x. And then I'll get a number. Of course, it's still going to be negative, but that's why they didn't give us a number. They had a variable they didn't get. Now, why is that positive?
It makes a lot more sense, though.
Yeah, no, this is correct. The question is, what's the decimal after the 2?
Yeah. Should I plug that in at t?
Hold on a second. Let me show you how to do. If you push math on your calculator, go to the bottom, you should find NINT.
F-N-I-T?
Yeah.
N-I-N-T?
Yeah.
Okay.
Hit that.
Oh yeah, here's the integral. 0 to 10, 1200 x minus 100 x squared d of x.
Well, you need to multiply that by, that function needs to be multiplied by e to the minus 0.04x dx. And then you need to go from 0 to 10.
And won't let me take away the dx before the parentheses.
You don't need dx. When you're doing numerical integral, you don't want dx. In other words, if I was going to do the following, if I was going to do this, here's the way I would type it in. Like that. In other words, you need four things. You need the function, you need the integral or the variable of integration, which in this case is x, and then you need the limits of integration. Excuse me, this should have been a 4 there. Yeah, sorry. So you want to type it in almost exactly the way I typed it in here. Only thing is I typed the function times e to the minus rt, and I don't have to do a comma x. This knows that it's integrating with respect to x. So I only need 3 things in Wolfram alpha. Oh, and I got one too many parentheses. That's why it's telling me mismatched. Maybe it'll give me more digits if I do it in there right. More cases? What does that mean? Wow, they give you the left rectangular mid right.
Oh wow. Okay, so I think I got it.
Oh, good. What's the digit after the 2? This says 21,000.
Yep, I got it right. Okay, so it's actually 21,394.16458.
Like that?
Yep.
Wow. Scared to hit check answer anymore.
Yeah, I know.
Okay, so now to get the accumulated amount of money, we want that number times e to the RT. So I want to multiply this by e to the 0.4.
Multiply that number times e to the 0.4.
21,394 point whatever times e to the 0.4. And it might be important that you not round off. Because you could accumulate some round off error potentially here.
Yeah, I pulled the whole number. I got 31,916.34. And that's rounded.
Fantastic. Well, if nothing else, you learned out how to do NINT on your calculator.
Yeah, The other ones will be easier now that we know how to, because I'm pretty sure it's just Wolfram alpha rounding error.
I'm dying to know what's going on with Wolfram alpha, why they didn't give us another digit there. Okay, let's see. The present value of a continuous stream of income over 4 years when the rate of income is a constant 40,000 per year. So the function is that. So we want the integral of the function times e to the minus RT. The interest rate's 0.08, and it's 4 years. So it's e to the minus 0.32. No. It's 3 to the minus 0.08 x dx from 0 to 4.
Will you jump to the homework so I can just read the rest of that problem, please?
Yeah, present value should be the same. Should be the same function. So you want to do this on your calculator?
Yeah, I can.
Let me do it in Wolfram alpha just to make sure that I'm going to get something similar. So it's 40,000 times e to the minus 0.08x. Going from 0 to 4.
Yep, except for, again, it didn't even give you a decimal.
So do you have decimals after that?
Yeah.
What are they? Two numbers?
4-8 rounded.
Okay.
That's weird why it's doing that.
It is weird. I'm about ready to buy whatever they charge for the professional version of this.
Huh. You see, you typed in 136925.48.
Yeah.
What's T?
T is 4. It's income over 4 years. I got a 4 in here. 0 to 4.
So what if you plugged in 4 for the X?
Well, you can't do that because that has to be integrated. So after you integrate that, in other words, what's the integral of that? It's e to the minus 0.08x divided by minus 0.08. So that's the integral. So I want to take 4,000 times that evaluated from 0 to 4.
It says round to the nearest dollar.
Are you kidding me? Wow.
There's
There's no excuse for that. Why would they do that? Other than to just trick you.
And that's why I was like, I bet you they just changed something compared to the last 4 problems.
That's why everybody's gonna That's why everybody's going to hate this, is the stuff they do like that.
Yeah.
You would never take a test where they would do that, would you? Where they would round one to the nearest cent and the next, maybe. I don't know.
Oh yeah, no, that's why everyone does bad on the tests. Is because they just do little things like that and you don't notice until you turn it in.
So we want to multiply that by e to the RT, evaluated at t equals 4. So now we want to multiply this number by e to the 0.32. And I would make sure you use the cents that you had, because that could easily make a difference.
I agree.
Oh, hold it. We don't need that. Excuse me. They didn't ask for the accumulator. We're done with that 17.
Oh.
Forget it. Let's go to 18. Finally. Wow. State that it diverges or converges. Ah. You're doing improper integrals. Wow. Interesting. Okay, let's find the integral of this thing first. Hold on. I can take the 3/2 out and integrate x to the minus 2 dx. So I get x to the minus 1. So it's a negative 3/2 x to the minus 1 evaluated from 2 to infinity. Okay, so that's minus 3/2 x, which is infinity, minus a minus 3/2 x, which is 2, which is 1/2. Times 1/2 when x is 2. Well, this whole thing goes to 0. So it's minus a minus 3/4, which is a plus 3/4. It's probably important that you understand how I did that.
I got you to just the last step.
Okay. First of all, I'm going to plug in infinity for x to get this first circled thing. And then I'm going to subtract out the evaluation of this thing evaluated at 2. Well, I still have my minus 3/2.
And when zero to the negative 3/2 power?
No, this 0 is what this thing evaluates at when I plug in infinity, because the denominator blows up. So the whole thing goes to 0. We're basically taking the limit of this as x goes to infinity, which is 0. And then we're subtracting the evaluation of this thing when x equals 2, which turns out to be minus 3/4. So I like 3/4 as an answer here. And it doesn't diverge because it doesn't go to infinity. For it to diverge, it would have to go to infinity. This is actually something we've never done before. Okay, good. They give us another one. Let's do this by the book. So that
I'm just kind of caught up. You did, so virtual 0 minus 3/2 times 2
times 1/2 times 1/2. When you substitute x, 2 to the minus 1 is 1/2.
But I thought x was 2.
It is, but the function ended up, after we integrated it, we had this, minus 3/2 x to the minus 1, evaluated from 2 to infinity. So that's the same thing as minus 3/2 over x minus a minus 3/2 over x, taking the limit of this as x goes to infinity, well, first of all, we take the limit of this as x goes to infinity, which is 0, minus the limit of that as x goes to 2, which is going to be a negative 3/4. In other words, this part of it goes to 0, this part of it goes to minus 3/4. So we have 0 minus a minus 3/4. When you're doing these improper integrals, an improper integral is any integral where one of the limits of integration is infinity. I find it easier to just substitute infinity rather than substituting x and then taking the limit as x goes to infinity. I just substitute infinity. So it really is the same as minus 3 over 2 times infinity minus a minus 3 over 2 times 2. So that's what we're looking at when we evaluate that thing from infinity or from 2 to infinity.
Okay.
And this part here is 0. That part there is 0. Minus 3 over 2 infinities is 0. But this part here is minus 3/4. So, all right, let's do this one because this is the same kind of problem. So first of all, let's integrate this thing. And we can write it as, always write it this way. In other words, remove the radical sign immediately. What's the integral of that?
Hold on a second, write it down.
I'm not even sure Wolfram Alpha will give us a number for this if we have to put infinity in there.
Okay.
But we don't need it anyway. We can manually evaluate this. So this becomes what?
Okay, so we want to pull out the 6.
Yeah, we don't need to for the moment. Let's just leave it there for the moment. Let's add 1 to the exponent.
So it would be negative, or it would be positive half.
Divided by a half, which is the same as multiplied by 2. So the integral is 12x to the 1/2, and we have to evaluate that from 3 to infinity. So the left side is what?
Zero.
No, this one,
12.
notice that it's this. That's infinity.
Oh, because no matter what, it's
Square root of infinity is infinity. The only time it goes to 0 is if the infinity is in the denominator. Okay, and we're subtracting, well, as long as this is not infinity, then we know our answer diverges, right?
Mm-hmm.
In other words, it doesn't matter what number I put in here. Since I'm going to substitute 3 for x, this could be 3 million, it could be minus 2, it could be any number at all. If I put any number at all in there, the answer is infinity. The only time it's a problem is if this was also infinity. In other words, if I get infinity minus infinity, then I don't know what that is. But if I get infinity minus a number, that's infinity. So it diverges. Good. An easy one. Okay, so let's have you do this one. What's the integral? I mean, what's the result of the integration?
Oh, just a quick question. It doesn't matter that the d of x or dx is on the numerator, does it?
Not at all. You could separate that and put it out here, or you can leave it in the numerator. In other words, it doesn't matter. That's the same as what I wrote. So we really have the integral of 9x to the minus 2 dx. So what is this?
9x to the minus 1 over 1.
Over negative 1.
Okay, I always get that mixed up. That's whether...
Well, just always divide by your new exponent. Whatever the new exponent is, just divide by that.
Okay.
Okay? So it's this, which notice is this. And we're evaluating it from negative infinity to negative 4. Well, when I put in negative infinity, so we got two things. This is what it's going to be at negative infinity. This is what it's going to be at negative 4, and I'm going to subtract them. So the first part on the left is minus 9 over negative infinity. The second one is minus 9 over minus 4.
Wouldn't it be the other way around?
Yes. Thank you.
I like it when I catch stuff like that. It's like, ah, look at it. I picked something up.
So the first one is minus 9 over minus 4, and I'm going to subtract out minus 9 over minus infinity. Well, what does this go to on the right?
On the right would be to infinity.
No, because the bottom is what blows up.
That's going to go 0.
Right. So the answer is 9/4. You got more?
I have 4 more.
Okay. Well, since it's an improper integral. See, I don't know that your calculator will do indefinite integrals. I think to use NIT, you have to have limits of integration. Well, let's do some factoring of this. I didn't forget how to factor. There's the numerator. Let's see, that's 12x squared minus 4x, okay. And the denominator factored is 2x times 2x squared minus x. Wow.
All right.
Hold on a second. That's not easy to integrate. Could actually factor out.
If you type that in Wolfram Alpha, just the fraction portion of it, not the limits.
Let's see what happens, yeah. Okay, so first of all, let's take this 2 out and get rid of this. Okay. Yeah, Wolfram Alpha should give it to us, and then we can evaluate it on our own. Because Wolfram Alpha, I think, will give you an indefinite integral. So we want net of 3x minus 1, 3x minus 1 divided by 2x squared minus x.
Don't forget the 2 on the outside of the interval.
Yeah. 2x squared minus x. Three x minus 1 over 2x squared minus x. Okay. So I want a 2 times that. Ooh, it won't let me do it. Yes, it will. Okay.
And then if you go down, you should be able to take, we're not taking the derivative of it, right? We're taking the...
We can actually deal with this. This is the result here. So let's start there. In terms of evaluating it. Actually, I'll bet you Wolfram alpha does accept infinity. It's just I don't know how to put it in. So we've got 2 times 1/2 log of 1 minus, what's the upper limit of integration? Negative 2. So 1 minus a minus, hold on, 1 minus 2 times negative 2. So that's 1 minus a minus 4. Plus the log, oh wow, can't take logs of negative numbers. What's the lower limit of integration?
Infinity, negative infinity. So it's got to be the...
Why would they do that to us? Give us a number where the log is a negative number. Can we figure out if this thing diverges anyway? In other words,
I think it does.
whatever that is, this right here goes to infinity.
Mm-hmm.
And this is a complex number.
I think it's going to be infinity.
So we have a complex number up here also. Well, let's try divergent. I guess the advantage of this is if it's not right, we get another chance or not?
Yeah, I think it would. Divergent.
Boy, I'm not sure exactly what we were supposed to do on that, though. All right, we won't have that problem here. The problem of having to take the log of a negative number. You know what I think it is? When they gave us the answer for Wolfram alpha, they forgot to leave absolute value marks around there. When you take the integral of that, you actually get the log of the absolute value. So we were okay there. We weren't taking the log of negative numbers. And it still came out to be divergent. So this one, what do you notice right off here?
It's just like the substitution method.
Good. In other words, what we notice is that the derivative of that is the same order magnitude of that. So I can do this by substitution. Let's do it the easy way. Oh my God. Load up my computer. X raised to the 5th times E raised to the, oops, raised to the minus X raised to the 6th. X to the 5th, e to the minus x to the 6th, so we end up with e to the minus x to the 6th over 6. And we want to evaluate that from negative infinity to positive infinity, correct?
Yes.
Okay, e, so that's 1 over e to the x to the 6th, right? That's what this is?
Yeah.
Okay, so I'm going to plug in infinity for my first evaluation, which gives me 0. And then when I plug in negative infinity, notice I also get 0. Because negative infinity to the 6th power becomes positive infinity, so the bottom still blows up again. So I end up with this, 1 over 6e to the infinity to the 6th power minus 1 over 6e to the infinity, the negative infinity to the 6th power. The bottom blows up regardless of whether this turns back into plus infinity or not. In other words, both of these go to 0. So we got 0 minus 0.
Which is divergent or 0?
I don't know. That's actually 0 minus 0 might be the indeterminate form. If I say infinity minus infinity, that's indeterminate. 0 minus 0 is not. That is not the indeterminate form. So I'm comfortable with that answer, I think. So let's integrate this. What's the integral of that?
Okay, so it would be 5x minus 8 to the 4th divided by 4.
Also divided by the derivative of the inside.
Oh, that's right.
Okay? So we want to evaluate that from negative infinity to 1. think we can see what's going to happen already. When I evaluate it at 1, I get a number. When I evaluate it at negative infinity, what am I going to get?
Zero.
No. Plug in infinity for x, or negative infinity for x.
I thought 5 was... No. Yeah, so it'd be a number, infinity?
Yeah. Well, if it's in the numerator, if your variable's in the numerator and you're plugging in negative infinity, then this is going to go to infinity. The whole thing evaluates at infinity. Whether it's negative infinity or not doesn't really matter. It diverges. Because you have a number minus either a positive or a negative infinity, that's infinity. You get that?
Yep.
Oh. Interesting. Negative infinity to b is the same as the negative of b to negative infinity. Why does that matter? So to go from negative infinity to 1 is the same as taking the negative of this and going from 1 to negative infinity.
Oh, it's going to be the digit, because if you had negative infinity on top, it would go to 0, wouldn't it? Because it'd just be a really, really big negative
Well, I
number.
did this whole thing wrong anyway. I had this as a positive 3 and it was a negative 3. That's the problem. It was a negative 3. So when we add 1 to it, we get a negative 2. Doesn't really matter what this does. What it means is that now when we plug in infinity, the x is in the denominator and it goes to 0. So the only thing we need to figure out is what the first part does when we plug in 1. We don't need to use their little technique there. Although that answer bothers me a little bit, but...
So could you write out
5x minus 8 to the minus 2 divided by minus 2 times 5. So divided by minus 10. So that's the integral. Evaluated from 1 to negative infinity. Well, when we put 1 in there, we know what we're going to get. When we put infinity in there, we're going to get a 0. So all we need is the 1 part. So 5 minus 8 is minus 3 to the minus 2 power divided by minus 10 minus 0 when we put infinity in there. So what is this? This becomes 1 over minus 90. Minus 1/90th. See how I got that?
Yeah.
Oh, one of these again. Lovely. I feel like, I don't know why we got that one last time wrong on this, because I feel like I've been doing it exactly the way they said to do it. And in fact, we got the right answer doing it that way. We just had the decimal wrong on that first one.
Yeah.
Perpetual stream of income that's your rate of income. Find the capital value at an interest rate of 6% compounded continuously. Now, the capital value.
Is that r prime of t? Because isn't it the rate of something?
No, well, that would be r prime of t. You're right. That's a derivative function. They don't call it that. But notice they don't say find the capital value at the end of 5 years. So they're not going to give us a t. The capital value, there's some other function here that I don't know what it is. So this may be one we have to do a help me solve this.
That's fine.
It's the same formula. It's the same formula as present value, only it goes from 0 to infinity instead of 0 to a specific time.
Okay.
So it's exactly the same as present value, only we go from 0 to infinity. Okay. That's a different function, right? No.
Yeah.
Is it?
The last one was 800.
Okay. So we've got the integral of 900 e to the 0.02t times e to the minus rt.
I'll see if I can get that in mind.
Good idea. Yeah. 900 times nth of e to the minus 0.04t.
Ooh, I don't know how to do infinity on the calculator.
Well, good point. I'm not sure how to do it either. Nth of...
Unless I could just put in like 10 million.
Probably not. Because it...
I got 0.
Okay, this result makes sense because the answer is going to be e to the minus 0.04x divided by minus 0.04. When you take 900 divided by minus 0.04, you get this number here.
Is that 0 relatively?
Well, no, we got to evaluate it now. So our result of the integration is this. And we're evaluating it from 0 to infinity. Well, when I stick infinity for x, what am I going to get?
Infinity?
Now, remember 0 because the e to the 0.04x is in the denominator. In other words, this is the same as this. So the moment I stick infinity in for x, the whole thing goes to 0. So that goes to 0. And then I'm subtracting, sticking 0 in for x. So the whole thing goes to 22,500 and it's being subtracted. So I got a negative 22,500. The answer is 22,500. 6%. Did I use the 6% here? Yeah, because we had 0.02 and negative 0.06. So that should be right. All right. Want to go back and give a shot at some of the others?
Yeah, looks like we have time.
What can we do? Well, we got about 12 minutes here.
I think 15 is the only one that we really didn't. I'm trying to remember. At 15 and 5.
Let's do a similar exercise. So, we know the net present value is the integral from 0 to 10 of f of x times e to the minus rx dx. So that is from 0 to 10 of 6,000 e to the minus 0.02x times e to the minus 0.04 x dx. Okay, so that's 6,000 times e to the minus 0.06 x dx. Evaluated from 0 to 10. Again, can you do that on your calculator?
Yeah.
Let's see, first of all, whether they want it rounded to the nearest cent. They do.
Four five 118.84 rounded.
That's pretty crazy when we have to use two calculators to do this. Actually, we didn't, but I mean, we could have gotten by with just yours. Now we want to take this number and we want to multiply it by e to the RT, where t is 10. So we want to multiply that number by e to the 0.6. Rounded to the nearest cent.
To the 0.6?
Yes.
82211.88 rounded. So I took 45118.83.
I did it wrong. It's not e to the 0.6, it's e to the 0.4. Sorry.
Oh, okay. That's easy to fix. That number times e to the 0.4. 67309.39 rounded.
Something's wrong with that. Did you multiply 45,118.84 times e to the 0.4?
Yep.
And then again, the rounding off could get me here.
I can give you the full number.
Well, here. No, that's not what I mean. I mean,
Oh, the Wolfram added.
yeah. In other words, I might need a couple more digits, actually. Yeah. On the first number, give me another digit or two. 0.84 was round.
So 0.83639.
That's all I need. Okay. So I get an answer of
That's exactly what I had.
67. Oh, I didn't hear your 6. I just wrote down 7309. I wondered. That's why I said it can't be right, because it's got to be a number greater than 45,000.
Yeah, no, that's the same thing I got.
Yeah.
67309.39.
Okay.
Alright, I remember 5 took us like a half hour, and we only have 5 minutes left, so I can always go back to that, even though I have a...
No, that's it. Yeah. You're going to need... If you use Wolfram Alpha, you might be able to get this.
Yeah, that's what I was about to say.
We tried to do that manually, if I remember right.
Mm-hmm. Took me a page and a half.
Which was crazy. Absolutely crazy, yeah. Try using Wolfram Alpha, and you should be able to get that one.
Okay.
Okay? All right. Should I type save and log out here, or does that screw you up at all?
No, save and log out, please.
Okay.
And then we owe you for 2 sessions now, correct?
Yeah, 96.
Alright, and should have that to you by the end of the week, but we'll definitely get that to you.
I'm not worried about it, Sean. Whenever is fine.
Alright, and then
Now,
this is the end of the class because all I have is one test left.